doesn't have to account for atmosphere
Right,
center.
that's why we built it in the first place. But of course what astronomers want now are these bigger telescopes because of that sensitivity factor I told you about.
So what about
And if you had your choice, you'd build this 30-meter telescope in space.
so what's the impact when Hubble looks at a planet? I'm assuming there's an atmosphere around that planet.
Right, so the problem that Hubble has about doing the planet investigation, it's not quite big enough an aperture. So, you know, you need the bigger aperture to acquire the sensitivity you need to make those spectra. And, you know, here's kind of what the dome looks like for the 30-meter telescope. And here's where it will be built, maybe on Mauna Kea. Here's Keck, here's Subaru, here's Gemini, Canada, France, Hawaii. And it's actually not at the summit, it's down off the side. And here's an artist's rendition of the laser guide star operation from this telescope. Now, there's a lot of politics here. This is a $1 billion project, maybe a little more. And Gordon Moore, the Intel founder, wants to donate $250 million or so to the project. And you got to remember that he lives on the Big Island. And this is literally in his backyard. The original plan was to build a telescope in Chile. And he said he was going to withdraw his donation if they build it in Chile. He doesn't want to fly down to Chile to see it. You know, whatever. So that's a factor. And of course the native Hawaiians and other groups are protesting. And I think they agreed to disassemble 3 telescopes up here to build this one, a new one.
Yeah.
They thought they had an agreement, but so I don't know what's going to happen. The 30-meter telescope project people are, you know, they're only in favor of doing whatever is legally correct. So they're just following instructions basically. But you know, it'll be.
So I'm an amateur astronomer with a 30-meter compensated telescope in my backyard.
Right. Yeah.
Okay.
Wow. So there's lots of simulations and modeling of what this telescope can do. The center part of the universe, for instance, you know, here's a simulation of how those orbits go. This is what they're currently working with. There's an upgrade plan for Keck, next generation adaptive optics, but this is what the 30-meter telescope would give. And when the animation quits, you'll see the number of orbits they can determine. So lots of cool science to be done with 30 meters. The ones I like are, let's see, methane rain on Titan, and I mean, can you imagine that they want to see methane rain on these moons of these planets in our own solar system? Nitrogen geysers blowing in the wind. I'm trying. Okay. It's very complementary to the James Webb Space Telescope. These are plots of things like sensitivity and resolution as a function of wavelength, and you know, it kind of fits in. Here's the big radio telescope in ALMA, the microwave telescope in northern Chile. Here's JWST, and these red dots are the instruments associated with the 30-meter telescope. And a cool thing here is Brent Ellerbrook used to work at the Starfire Optical Range. I say the best way to transition technology is through people. He is now in charge of all the instrumentation for the 30-meter telescope. So it's really, I'm kind of proud of the fact that he cut his teeth on this stuff at the SOR. The Europeans are going to build this telescope. It's a dead certainty. They've got the money. They've got all. The Chileans are completely the opposite to the Hawaiians. They want the telescopes, and They donate the land to them. They actually own the land. And so it helps their economy. They're really in favor of the science, and it's a great working relationship. And this is their array of laser guide stars that they'll use on their 39-meter telescope. If you want to read more about this, there's a book written by Bob Duffner, one of the AFRL historians, Adaptive Optics Revolution in History. It talks all about the contribution made by the Air Force and a lot primarily by the work done at the SOR. I wrote the foreword to the book, and I was totally shocked when I first saw it. This is a picture of me when I was a kid in Dayton, Ohio, with my first cardboard telescope, which I bought at a garage sale for $1.50. And,
I remember that.
And what I like are the cuffs on my pants here. See that? It's really cool. This was in our backyard in Dayton. Not a very good astronomical site. So, you know, people have said that it's ideas that change the world, and I think that laser guide star adaptive optics might be one of those ideas, at least in the world of science. And I was really kind of proud to see that the National Geographic gave us a 2-page spread in the special edition they did on 100 scientific discoveries that changed the world. So, this is my picture. Any questions?
I'm thinking, as we're talking, 52 years ago in college, I was